Hello everybody and welcome to another video. I'm Bolboaca and I'm coming to you from the Mozaic Works studios, and what I have for you today is a piece of software development history. Where does model view controller come from? A very used pattern today, but when did it start? When did we start using it? Before we go on and dive into this topic, I'm coming after a very successful CPP Europe, and I'm preparing another architecture course, software architecture course, for the next week. And so I thought that it would be fun to geek out a bit about software development history, something that I really find very interesting. Now, many people think that model view controller is a relatively new pattern. I've had conversations a few years ago when Microsoft has launched ASP.NET MVC, and there was this feeling that, this is something new, and developers were telling me, look, we have to learn this new thing, which is MVC. And I was like, that model view controller started in 1960s. Yes, it is. So at this point in time, it's a 60 years old design pattern. And when I saw on Quora that Alan Kay had an interesting answer to and a detailed answer about the origins of model view controller, I thought, okay, let's take a deep dive. And I hope you'll enjoy this. So let's check it out. So the question is, it's on Quora, what is the origin of model view controller? And the answer is Alan Kay, answer May 21, 2022. And first of all, if you don't know who Alan Kay is, he's fundamentally the originator of object-oriented programming. Alan Kay has been the person who thought about computers in a different way, about computers in a way that would allow learning, that would encourage creativity. So his ideas are the basis for a number of things, for object-oriented programming, for graphical user interface, for the modern iPad and tablets, for a number of very interesting things. And back then, when Alan Kay was very well known and very active with the innovation in the area of computers, let's say in the golden years, there was a high amount of excitement related to these new ideas that would transform computers from something that was used by professionals and technicians in a very big room, and in a very structured, let's say, process, because there are lots of limitations. For example, you had to write your program, then print cards, and then take those cards to a technician. And the technician, when they had the time, the operator, I think it was called, the operator would load the program into the huge computer and run it. And if something didn't work well, you would get back a huge piece of paper printed with the stack of the program and what happened to it. So it was basically the output and everything that happened to the memory of that computer. And imagine debugging that, right? So this was roughly the process back then. And there was this time when people started thinking about, okay, how about we build other types of computers that fit different types of usages, like have graphics, you know, huge innovation. How about we would have some graphic in our computer and user interface, but nobody knew how to do those things, right? So it had to be the work of some innovators on how to do this. And this is what Alan Kay is hinting at. He's talking about Ivan Sutherland. Ivan Sutherland, the inventor originator of interactive computer graphics, had the idea of a clipping window to see a part of the very large Sketchpad world. I will go back to what Sketchpad is in a minute. This wound up being a program structure roughly like a camera, which had an aperture that could be of any size relative to the world and would show that portion of the world on the screen. Each Sketchpad object had a method that would render the object in the world, and the windowing apparatus did the job of transforming world coordinates to window coordinates. This was done as part of the rendering operation. So already we see some things that were very new for that time. A window, a clipping window, which is something we are very used nowadays, and transforming the world coordinates to window coordinates. Again, something that happens, and if you've learned anything about computer graphics and how things happen inside the operating system and inside graphics card, this is a very common operation, like transforming world coordinates to window coordinates. Another interesting thing is that this already hints at object-oriented programming, right? A window is an object and it has a method render that would render the objects. Well, actually, a sketchpad object, right? We already see the mention of a sketchpad object. Right, but what is Sketchpad? So let's look quickly. This is a video on the Internet Archive. Alan Kay doing with images makes symbols part 1. It's basically a video about the history and the talk by Alan Kay about the history of graphical user interfaces. And around the minute 4, let me show you a little bit on how Sketchpad was running. And remember, this is 1962 or 1963. I got two different years. So Ivan Sutherland is using actually a special pen to draw on a screen. He also pushes some button here on the left, some buttons. And this is an amazing thing, right? He's drawing on this board with a pen, and then he gives the command to transform the shape into 90 degrees angles, and Sketchpad manages to do that. And this is the program, right? Remember, 1960s. Amazing. All right, and now he can zoom in, draw another line, draw some more lines. And now what he wants is, okay, let's do some parallel lines, I assume. And then let's draw some more. Right, what he's doing here. So cool. I imagine he's cutting things out of the segment. I haven't actually seen this part. I'm seeing it the first time with you. Awesome. And now we have this. Look. Now, of course, today this might seem very simple, but man, this is impressive for 1960s. Now let's see another example. Right, drawing some shapes, multiple triangles, a circle, a perfect half circle. And now I think he's matching the distances there. Yeah. and we are getting a transformation again. All right, so enough of geeking out with this thing, but really honestly it's a very, very impressive piece of history. Okay, so this is what Ivan Sutherland was doing in the 1960s with Sketchpad. And the Wikipedia entry of Sketchpad is that Sketchpad is a computer program written by Ivan Sutherland in 1963. Some sources say in 1962. So, okay. In the course of his PhD thesis, for which he received the Turing Award in 1988 and the Kyoto Prize in 2012. It pioneered human-computer interaction and is considered the ancestor of modern computer-aided design programs, CAD, as well as a major breakthrough in the development of computer graphics in general. For example, the graphical user interface was derived from Sketchpad, as well as modern object-oriented programming. Using the program, Ivan Sutherland showed that computer graphics could be used for both artistic and technical purposes, in addition to demonstrating a novel method of human-computer interaction. So basically, this guy has done a number of innovations at the same time, right? So 1963, 7 January, he introduces Sketchpad. But what's interesting, he was asked, so let's see if I can find this. He was asked about these innovations, and yeah, quotes. How could you possibly have done the first interactive graphics program, the first non-procedural programming language? Remember, it was procedural language back then, so you would have to something like C, right? The first object-oriented software system all in 1 year. And Sutherland replied, well, I didn't know it was hard. You have to... I have to be impressed by this. All right. So, let's go back to Model View Controller. Ivan Sutherland in 1962, the building-sized TXT computer working with Sketchpad on a bridge design. So this was mostly for CAD, right? The next version of Sketchpad was a 3D system, and it supported 3D multiple views of the world. It was done by Timothy Johnson. The next major project by Ivan was the first virtual reality head-mounted display, 1960s. And this required tracking the head of the wearer and using this to sample from the interior 3D world for each eye. So there was a similar software structure like a telescope or camera that had one end in the virtual world and had the other on the display face. Both to be visualized objects and the cameras had 6 degrees of freedom. The virtual world side was sometimes called the camera and sometimes called the window. The real world side was often called the viewpoint. At Xerox PARC, this was renamed the window to help explanations to Xerox. When I was a grad student of the University of Utah, I overlapped with Ivan the HMD project and its approach, meaning there is a world with virtual objects, and these include camera objects whose purpose is to look at parts of the virtual world and send these to be displayed on windows on a display. The simple linear equation for coordinate transformations was now many degrees of freedom matrix that required quite a bit of special hardware support that had to be built from scratch. So I guess this was the first graphics cards. At some point I started thinking about other than graphical virtual objects in the everything is an object ideas I was pursuing. So remember, Alan Kay was thinking about object-oriented programming. The idea was that every object should know how to render itself, and this should be combined with a windowing viewing mechanism. A fun thing was the idea to use multiple windows to show different aspects of the objects in the view. I first saw this in Sketchpad 3, then in the Engelbart system in the late 60s, mostly used for filtering detail, and used the idea in the Flex machine that Ed Cheadle and I did. If you don't know the name Douglas Engelbart has shown for the first time in history how to use a mouse. He has a video which I'm sure you can find somewhere on the internet, called the mother of all demos, because it demonstrates Windows, it demonstrates basically graphical user interface, it demonstrates the usage of a mouse, which they built for the first time, and so on. So this is, you know, a big part of history. If you look today at that demo, it's like, we are using all those things for so many years, we don't even remember where they come from, but that's where they come from these very innovative people. Okay, so LNK was following everything is an object, and then you had this thing where you had the world and you had to show a bit of the world through different views. Get it? The earliest versions of Smalltalk were simple and slow and included multiple windows and turtles that could be part of the window that would then clip what the turtle drew. Another early plan, not done until later, was to have a slippage scheme because the simulation frames from the model could often be computed much faster than graphical rendering of the view, and thus one would like to decouple the updating of the semantics from the updating of the display. So we have the same problem today, right? We want to decouple updating of data from updating of, you know, the internet page. This was later actually done in a principled way when MVC was implemented. Shortly after Smalltalk 76 was done, we were visited by Trygve Renskaug, I hope, from Norway, who was very interested in large-scale planning. He was indefatigable. All right, Alan, you're using complicated words now. And decided to do a real planning system in the new Smalltalk. I attribute the first formal and working examples of MVC to Trygve, who, among other things, used them to view and change a complex changing schedule and to have different windows show lists, Gantt and PERT charts, each of which would be edited directly and would automatically cause the model to update itself. So multiple views on the same model, and if you change something in a view, it reflects on the model, which reflects on the multiple views. Adel Goldberg and Dave Robson got very interested in this and took it further to the general idea that there is a model system, which has the semantics of the system, a viewing system, which can get the needed parts for a model for each view and do the screen painting, and the controller system that deals with the input devices employed by the user. Does the sometimes difficult inverse transformation on the view to find what is being interacted with and informs the model about needed charges. This more formal system was put into Smalltalk at some point, maybe not until Smalltalk 80, and both overkilled and underkilled. Part of the underkill was that originally there was a class model with a protocol for things to be viewed by member of class view. But since you wanted to view everything, the model protocol should be part of class object, etc. This eventually happened. And so forth. For the simple things should be simple part, there needed to be a default views that would be automatically included in any class definition. One of these later that was much used, Morphic, was done by John Maloney, originally for Self and then for Smalltalk. Similarly, having default controllers was very useful. This whole framework was a very useful way to separate concerns, and I think even more should be done pragmatically with the details of creating MVC subsystems. Okay. So what we have here is we have a model system that has the semantics, viewing system, and the controller. The ideas around 1976, 1977 included by default in Smalltalk. I assume Smalltalk 80 was around 1980s. So okay, maybe not 60 years, about 40 years old. 60 years in the making, let's say, and 40 years old as a pattern. And that's where model view controller comes from a very real problem. And one thing that I keep seeing again and again in software development, and it's something that bugs me, you know, is because we have these gems and then we start going around them. Like I remember doing desktop applications in 2000s, end of 1990s, beginning of 2000. Desktop applications in Microsoft framework or foundation, something, MVC, using C++ under Windows, and what they recommended as a pattern was document view, which was basically model view controller, but without all the necessary things. So much worse type of pattern, because you would have a model and then you would have a bunch of documents that would show part of a model. So for example, if you think about an Excel spreadsheet, you would have, let's say, a view that has the numbers in the Excel, and another view that would show a graph based on the numbers, and if you change the numbers, then the graph changes, and so on. This is just a simple example, but there are much more things like this. But the way we did that was by using two notions. A document and a model, right? And not have all the model view controller. So completely missing the controller, which is a very important part of things. And this was happening in 2000. So it's still, 20 years ago, but 20 years after MVC was used on a large scale in Smalltalk. And then it took, how long did it take for us to go back? So when we went to internet, to web applications, again, we did completely different things for a while. And at some point, we saw a lot of MVC frameworks coming up. And I think probably the one that brought this, I'm not sure, but I think culturally, the one that brought MVC back to life, let's say, in our software development thinking was Ruby on Rails. And it started to get very used, and then other frameworks started saying, okay, so maybe we can do model view controller for internet applications. And then we started seeing things like, I don't remember which was the first one in Java, but there was one framework in Java. Then it moved to Spring MVC. And then finally Microsoft came back with ASP.NET MVC. After going through another trip when we were doing desktop applications using Microsoft, I don't remember the exact Windows Presentation Framework, WPF. The initial way developers were writing code was pretty bad, coupling a lot of things together. And then they came up with this model view model type of framework, which is, once again, why don't we use the ones that were tested and validated in years of history? No, we have to invent something new. So model view model, which worked, but fundamentally, if you had the support, you could do model view controller very, very easily and solve a lot of the things here. And now the problem is, let's criticize a bit model view controller today as well. One thing that I often see with model view controller today is that it's very clear what you need to have in a model. So if you think about web application, what will you have in the model? Well, you will have classes that read and write to tables from the database. Very commonly, one class per table, because that's the easiest way to do that. Not the best idea, right? There are other ways of doing that, like CQRS command query request separation, which basically means that you would have separate classes, separate commands for update, insert, and so on, things that change, and separate commands for reading, because queries are fundamentally different from commands, right? But okay, going back, it's still quite clear, you know, we have to have in the model things that relate to the database, of course. What do we have in the view? Well, we have things related to what the user sees. So that's where you will see things like generating HTML, or in a way or another, or some kind of markup that you use to generate HTML more dynamically, and so on. All right, fair enough. I mean, views are pretty good, I think, as they are, except for the fact that we still don't have some standard set of components, of reusable components that we can actually reuse between the different applications. But okay, we'll go with it. Everything else, because it's model view controller, so of course everything else you move into controller, right? Now, of course, if you've done this, you know it's a very bad idea, because it leads to fat controllers. And the idea with the controller is that it's supposed to be very simple. Very, very simple. So what you need to figure out is that, you know, the idea with MVC is that the model, the view, and the controller are three things that change separately. The model changes when the data structure changes. The view changes based on needs for the user interface. So for example, a view can change if you want to change the color of a button, let's say, or if you want to change the text on a button, or things like that. Completely unrelated many times with the database or anything else. And controllers change when something changes in the interaction between views and the model. So perhaps you want in the view to show some more data, or some other type of data, or, you know, and in that case you need to change the controller. But in addition to that, we still have other responsibilities, like if you have a form and you input some data in the form, you need to have validation. And if you have validation, completely different concern than anything else, than controllers and so on. This should be a validator type of class. Okay. So the point of all this thing is do not use only model views and controllers if you're using an MVC framework, whether it's ASP.NET MVC or Spring MVC or Rails or whatever else. A Python framework for MVC, whatever else you're using, like Flask. So don't use those. You need to have other types of classes for other types of concerns, because those responsibilities will change separately from these ones. All right. And also the one final point. It's very interesting to me that object-oriented programming has started from the ideas of objects. I was paying attention to this while I was looking at I was reading the Quora answer by Alan Kay. He didn't mention class once. These people were not thinking about classes. They were thinking about objects. This is object-oriented programming. So the fundamental thinking in object-oriented programming and the thinking in object-oriented programming that we should have today is about objects and how objects interact with one another. Classes are there just to spare us from duplication. We classify objects into a class. So if you have multiple objects that are windows, perhaps you will have a window class that has some method like render and so on, and coordinate transformation. But it's object-oriented programming, it's not class-oriented programming. Whenever we think about things like inheritance or, well, large inheritance hierarchies, templated classes, generics, and so on, that is about classes. But we need to think about objects if we want to have a design that can resist in time, right? So pay a lot of attention. Don't try to stop doing class-oriented programming and try to start doing object-oriented programming, which means what object do I need? How does my object interact with other objects that exist there? And the way Rebecca Worsbrook, who worked at Smalltalk, develops part of Smalltalk, and the way she explained to me on this channel is that in Smalltalk you would have objects, like a world of objects that would come to life, and then you add your own object and figure out how it needs to interact with the other objects. And that's a whole different programming paradigm than the one we are using today, where we have a bunch of classes and we write code based on classes. Maybe we write some unit tests, although, well, I would highly encourage you to write unit tests. I would highly encourage you to do test-driven development, but I know many of you are not doing that. And then run the program, and we don't see the objects, we see the code somehow. Or we see the output, the views, right? Very different programming model. If you think in objects, if you think as, objects are in their own world and the world is booting up, and then objects are interacting to one another, so much different, and it's so interesting to see that, right? So this is what I wanted to talk about today. I hope you enjoyed this. This is, I was geeking out a bit about the history of software development, about model view controller, about the initial graphical user interface, about that period of huge innovation in the 1960s and a bit in the 70s. So great, and so many things that we have forgotten and that we don't think about anymore, even though we need them, even though we are going back today to a programming model that is closer to those times. Think about the cloud and serverless. So what do you have? You have a bunch of functions that run there, and there's data somewhere. So maybe, you know, those functions are something like the commands and queries, and then perhaps we would go back to something that resembles, you know, model view controller, but for the cloud, for serverless. And to me, thinking about these things is very, very rewarding and very, very nice. I hope it is the same for you. Thank you so much for watching. This has been it. If you enjoyed this, like, share, subscribe. If you found this interesting or intriguing, leave us a comment, and I'll make sure to answer those in a few weeks or so maximum. I still don't have a good schedule for answering comments, but I'll try to answer as soon as possible. And once again, thank you so much for watching, and until next time, remember to think, design, and work smart.